What is Coulomb's law? Well, you will learn something very special in this lecture about Coulomb's law. I will teach you the basic concept of Coulomb's law, derivation of Coulomb's law, bonus questions, best and easy explanation of writing Coulomb's law in vector form, applications and numericals. So watch this lecture till the end and you will learn something very awesome. Firstly, let me quickly revise the concept of forces between two charges. We all know that like charges repel. For example, consider two positive charges. We all know that they both repel each other. Now in physics, we do not say that they repel each other. Rather, we say that they experience repulsive force. Here, if I ask you that, how can you draw the direction of repulsive forces? Can you draw it? Well, many students do not know it. Let me draw it. This charge experiences repulsive force in this direction, and this charge experiences repulsive force in this direction. So remember that there are two repulsive forces. Similarly, consider two negative charges. We know that they also repel each other because they are like charges. So here, again two forces act on two charges separately. Secondly, we know that unlike charges attract. For example, consider a positive charge and a negative charge. Now in physics, we do not say that they attract each other. Rather, we say that they experience attractive force. In case of attractive forces, we draw them like this. So remember that attractive force are also two forces between two charges. Now here comes the most important question. If I ask you how much repulsive force exists between these two charges, or how much attractive force exists between these two charges, how can you calculate it? Well, it was first French scientist Coulomb who successfully calculated this repulsive force between unlike charges and attractive force between like charges. He put forward his famous law, which we call Coulomb's law. Thus, in simple words, Coulomb's law calculates the force of attraction or repulsion between two charges. Let me repeat it. In simple words, Coulomb's law calculates the force of attraction or repulsion between two charges. Here, let me teach you one important term which is difficult for some students. We all know that we measure mass in kg. For example, we say that 10 kg fruits. Similarly, we measure charges in coulombs. For example, let the magnitude or size of this charge is 0.5 coulomb and the magnitude or size of this charge is 0.3 coulomb. Now, if I say product of magnitude of charge, can you understand it? Well, it means that we multiply the magnitude of these two charges and we write 0.5 into 0.3. So note it down this basic concept which some students are not understanding. Now let me teach you what is Coulomb's law. Well, we have already learned that Coulomb's law calculates the attractive or repulsive force between two charges. Now consider two static charges or 2 point charges at rest. Let I keep them in vacuum or air. Let the distance between these two charges is r. The size or magnitude of this charge is q1 and the size or magnitude of this charge is q2. We already know that there exists repulsive force between them. Now the question is, how much repulsive force? Well, according to Coulomb, the force between these two charges is directly proportional to the product of magnitude of charges. Let me repeat it. The force between these two charges is directly proportional to the product of magnitude of charges. Let this is equation number 1. Secondly, Coulomb states that the force between these two charges is inversely proportional to the square of distance between them. Let me repeat it. The force between these two charges is inversely proportional to the square of distance between them. Let this is equation number 2. Now listen carefully. I combine equation number 1 and equation number 2. I write F is directly proportional to the product of charges. Secondly, F is inversely proportional to the square of distance between charges. Here, I am interested to remove the sign of proportionality. To do so, I have to place a constant. So I write F is equal to K into Q1 Q2 upon R squared. This is known as Coulomb's law. Here, this K is known as Coulomb's constant. Our K is equal to 1 upon 4 pi epsilon naught. Remember that K is actually the property of a medium. For instance, here the medium is vacuum. In case of vacuum or air, the value of K is approximately equal to 9 into 10 to the power 9 Newton meter squared per Coulomb squared. Thus remember that Coulomb's law depends on 3 factors: product of magnitude of charges, square of distance between charges, and the medium K in which charges are kept. Thus note down all these important points. Now let me teach you 3 important concepts. Firstly, where is Coulomb force acting on charge? Well, Coulomb force acts along the line joining the center of charge. For example, consider 2 charges. Here, I draw a line between these 2 charges such that this line joins the center of these 2 charges. Now the Coulomb force, either attractive or repulsive, always act along this line.